can get this code in physical gates, it means I don't need a computer anymore to run it. And it's only this long. But if I get it this long, then it actually almost goes better if you get all those in physical gates. If I get this whole thing in physical gates, it actually goes a little better. Okay, so, well, I'm giving myself 2 gigs. Now, how fast do you think you can get your oscillator to go? I think I can get it going 2 gigs. 2 gigs for my oscillator. So that only runs once. That runs for collision repeats because you got to bring the robot when the robots collide. Some of the parts move really quickly and some of the parts only move slowly. But to get all the quick moving bits that move further after the collision, you have to iterate it more times because you got to keep conducting the contact into the robot to get the leg to finally push to the side. Yeah. Because you got to keep conducting that mechanical hit through it. And then I've got a fair bit of hertz I can use. It's like I only have to hit, so do you want to just do a 12-inch robot? I had my heart set I'm doing with 16 inches, but this one should just be 12 inches. Just do it normal. It's just a normal one. Yeah. So 2 to the power of 12 is 4096. Yeah. So this thing is only 4K samples, and so if I get 2 gigs, so there's 2 gigs there. If I divide that by 4096, then I've still got left. I can do more iteration if I want. Yeah, and so I'm only looking 1 step. But that's right. So how many is, I just have to look at something. Go to robo.h.h. And so I'm looking for the iteration. So coal reps, you did 16. And fizz loops. And fizz loops 2 is 4, and fizz loops is 4. So I'm just going to check something. Did I actually use those? So there's physics 3. Okay, so yeah, I use fizz loops. Yeah, I use both. So then there's actually 16 iterations of this thing. It's so it can sees more of the resolution. Like it only does 1 motion, but it takes it forward as if it did it for more times in a row. Yeah, because it's got to see a little more in the future. So there's actually 16 frames in front. And I remember that the coal reps could have been more than they actually are, but the coal reps that help the collision iterate, that iterates the mechanical conduction, and 16 coal reps. But better is more. More is better. Okay, so you can just go divide all that by 256. Divided by 256. and then I got 2,000. 2,048. So with 2 gigs, I'm pretty much okay. Well, it's a bit of a bitch. So I don't have to put any iterations in it. I've still got 2,048. Lots of cycles left. So the tendon de-stretch code is, let's see. Okay, so you've gone through all the sticks, and how many sticks is there? Tell me how big the model is. There's there's 32 plus 16 robo sticks. That's more than I thought. RoboVerts is 20, yeah. But there's 32 plus 16 robo sticks. And they're not actually going to be, they're just going to be hard in it, so I don't have them as variables, they're just hard connected. Which is going to be a bit confusing. You're going to have to design this on the computer. Yeah, you have to precision generate it. So 32 plus 16 robo sticks. So that's 48 robo sticks. 48 sticks. 20 points. But that's not including the tendons. With the tendons, there's 3 times 8 times 4. 3 8, so 24. There's 96 tendons. Those could get pretty big. That's actually pretty big, man. It might end up being too big. I don't know, it's the first time I've done it. And then what else is there? I think that's what I was looking up. Yeah, that's actually pretty big, man. 100 tendons. Could you make it smaller than that? Might need to reduce the model. Reduce. Okay. So go back to the de-stretch code. This is like trying to get it to run on an Atari, and you'll see that it can't even do it. Yeah. So it looks like I get. Oh yeah, that's the dampening there. That's the dampening. It doesn't work without a dampener. Or it just oscillates out of control. The mechanical conduction and is dampening. Yeah. So what I do is I add where it's currently going to its position, and I use the advanced position instead of the position now. So if you dampen it, if you conduct it with the position in front, it actually acts like a dampener. Pretty cool, eh? and it's realistic-ish. But so yeah, it should work. Yeah, I reckon it's gonna work. Because if you do mechanical conduction, you reckon it doesn't matter how you do it, it's always at least a little bit realistic. So I get those two differences, then I get a length, then I get another difference with a constant. Yeah, that's all it is. Then you just add and take it. Amount equals L diff. Oh yeah. Yeah, so what I do is to dampen it, I use the length computed off the points in advance one frame. So I don't use the length now, I use the length in front. And then that gets over the oscillation out of control problem. This is my little friend. Don't need any nightmares today. So what you do is to de-stretch a stick, get the length of the stick one frame in advance, and then get the difference of that and the proper length, and then you just shift it, then you just add it left or subtract it on both points towards the center. Yep. And then that's fairly realistic. And then there's no F equals MA, but it gets that back from just all homogeneity. Yeah, it just counts as homogeneous, but I think maybe you're gonna have to sync it to real life a little bit, because it's got to, maybe it needs F equals MA, because you've got to measure the robot to get the weight of the robot. Maybe I have to. But if it all just counts as the same mass, and then it's just, the sticks are just tugging at each other. Yeah. So this is a pretty unrealistic one, but you know, it might work, because it's the most unrealistic one of the most realistic one, so it might be alright still. And so you just gotta, so then you're just running that de-stretch sticks. I'm mostly just running one thing.